Hello again, this is Miss Nakayama, and today's lesson is 6.1b, Modeling with Exponential Functions. So remember that data do not always show an exact exponential relationship, and when the data in a scatter plot shows an approximately exponential relationship, then you can model that with an exponential function. So one way we're going to talk about doing that is with a list of data, and we're going to use a regression model. Now, when you do these in your homework, you're doing them in Delta Math, you get to copy and paste the values. But I am going to review how to do this with the 36. And hopefully it's enough if you have a Casio. Few of y'all have a Casio. But I can help you when I get back to school knowing how to do it with your calculator because you won't always be using Delta Math. So first and foremost, what you're going to do is go to your TI calculator, clear it. You can always clear it by hitting memory and on and clear at the same time. It says memory cleared, it just kind of resets everything back to the default. Okay, so if you do that first, then go and hit the data button. Okay, so the first thing you're going to do is hit data, and then you remember you're going to see L1, you're going to see columns, and you're going to put this in the first column, 1, 2, 3, 4, 5, 6, 7, 8, and then you're going to type 620, type each of these numbers into the second column of 8. Okay, so after you do that, then you're going to hit data to put it in there, then you're going to hit second quit. I think I did not add that to my steps. Maybe it doesn't matter. But then you're going to hit second and data, and you're going to choose number 9, which you can scroll down to number 9. You can hit the number 9, or you can go up and go to number 9. But second data number 9 is exponential reg. And when you push that, or you get there, then you're going to have a screen that looks like this. So you're going to have the first one in L1, the second one in L2. The frequency is 1. But this one right here that says reg EQ, if you change that to yes instead of no, I think the default is no. If you change it to yes, I'm going to show you a really easy way to do the rest of the problem. And there is your model, y equals a times b to the x. So then you hit the enter button all the way down to calc, okay? And then you just hit enter again, okay? And when you do, I don't have the answer, but you'll see it up on your screen, okay? And your screen gives you the numbers of A and B. So when you do, remember that you're trying to put it into this function. Okay, our model is, as it said in the beginning, y equals a times b raised to the x. So a is 5.22. I'm going to carry it out just lots of places to make sure we don't lose anything. 522.886 times b is 1.196 raised to the x. So that's your model. I want to caution you, a lot of y'all miss these problems because you forget to put an equation. And in Delta Math, it says give the equation of your model. Y equals is what's always got to be in there. You wouldn't get it wrong otherwise. Okay, next, if the spending continues at this rate, what will the graduate's debt be 1 year after graduating? Okay, so am I looking for X or Y? I think y'all know if I'm looking for the debt, then I'm looking for the Y value, which means I'm going to plug in for X. Okay, and X in this case, after 1 year, this is the number of months, so X will be 12. But what I want to point out to you is if you go back from that screen that gave you the information, if you just go back to clear and actually hit table, and when you hit table, choose number 1 that looks like F with a parentheses on it, and then press enter, and then you're going to enter 12. It's going to come up with F of, and you're just going to put 12. You can close parentheses if you want to, but then if you push enter, you will get the answer to the problem, which is $4,499.38. So obviously you can go back in, y'all, and just go into this right here and plug in 12, which I think in Delta Math is usually what they want you to do. But if you're not, then I'm just telling you that's an easy way to do the problem. If you can remember, that's the point of having that on your table and being able to use that feature on your calculator. In Delta Math, he says use this equation rounded to the proper places, and so that's when you put, and it would be a little bit different. But again, you would show your work on your test, so you get full credit without any problem. Okay, let's look at the other kind of model that you have. So write an exponential function using 2 points. Write an exponential function y equals a times b to the x whose graph passes through these 2 points. Okay? Passes through these 2 points means that they are x and y. That's x and y, and that's x and y. So I can go back to this equation right here, y equals a times b to the x, and plug in. So my first one is going to be 6, that's my y value, equals a times b to the first. And then my other one is going to be 54 equals a times b to the third. So all I did was take this equation and plug this information to get 2 equations and 2 unknowns. And now the rest is algebra, and we should be able to do that. Now, I'm going to give you some hints of the easiest way to solve it is to take the one that has the lower power, which in this case is 1. So I'm looking at the ones with exponents. Choose the one that has the lower exponent. So that's this equation here. And I'm going to solve it for a. So when I do, that means that a is equal to 6 over b. And I'm going to take it and go plug it into the other equation. And when I do, I'm going to have 54 equals 6 over b times b cubed. Okay, well, b cubed is the same thing as b cubed over 1. So when I simplify that, b cubed over b is b squared. So this is 54 equals 6 times b squared, or 54 divided by 6 is 9 equals b squared. So b equals plus or minus 3. And I'm going to take that and I'm going to go plug it back in over here. And y'all remember from the last lesson, b can never be negative in these problems. It does not make sense in this context. So I know that it's positive in this case. So a is equal to 6 over 3. So a equals 2. And we just found out that b is 3. So that gives us an equation of y equals 2 times 3 to the x. Okay? All right, let's do one more of a different type in context. Okay, example 3. Sophie invested $6,600 in an account in the year 2000. The value has been growing exponentially at a constant rate. The value of the account reaches $8,700 in the year 2004. Determine the value of the account to the nearest dollar in the year 2010. Okay, so similar, to what we just did, but you just got to come up with the points. So 6,600 in the account in year 2000, that's like my beginning amount. So the easiest way to tackle that is to say, okay, well, in the beginning, I have at 0 times 0, which is the beginning, I have $6,600. And then after 4 years, I have $8,700. And I know that if I have 0, then 0, whatever number goes with 0 is going to be my a value. So I have my equation, y equals a times b to the x. And y is 8,700. A is 6,600. And b, I don't know, but x is 4. So I've been able to take this information, plug it all into this equation, and find only one variable left to solve. So I'm going to divide by 6,600. I like to deal with fractions because I don't remember how the decimals. And then when I take the 4th root of both sides, okay, that's how we solve that, just in case people don't remember. 4th root of this and the 4th root of that gives me b is equal to that nice decimal. So my equation is y equals 6,600, my model, 6,600 times 1 point, that long decimal, raised to the x. Okay, now determine the value of the account to the nearest dollar in the year 2010. So if I need to find it in the year 2010, that means x in my equation is going to be equal to 10. Because remember the beginning, it was 2000. So I'm just going to go and plug 10 in for x. And when I do, I lost my equation. There it is. When I plug in 10 for x, I'm going to find out that he's going to have about $13,167. And that is all we have with modeling for exponential functions. Thank you so much for watching. Please don't hesitate to email me or come see me if you have any questions. Y'all have a great day.